Hello.
Good afternoon, sir.
గణేష్ డిలే ఏమైనా ఉంది ఇంకా?
Good afternoon, all of you. Am I audible? Hello.
Audible,
Yes, sir.
audible, Ganesh.
Yes, sir, audible, sir.
Thank you. Thank you very much. So on behalf of BVC ITS, I welcome you all for this one-day workshop on natural language processing. Myself, AVSM Ganesh, head of the department, MCA. Today, we will conduct one workshop on this advanced technology. So, I hope all the participants, you will have much knowledge while completing this workshop. So for this workshop, first of all, I would like to say thankful to our honorable management, our honorable principal sir, and our honorable administrative officer sir, and various heads of the departments. So for this workshop, today's chief guest or today's resource person, M. Haritha Madam. She was expert in this technology. So I would like to thankful to Dr. M. Haritha Madam for accepting our request to conduct this prestigious workshop on behalf of BVC ITS, on behalf of MCA department. Now, I would like to request our IQAC coordinator, Sri A.N. Vijay Rajgopal Garu, to say few words about this workshop. Sir Rajgopal, sir.
Thank you, Mr. Ganesh.
Thank you, sir. You can continue, sir.
Yeah, okay. So today's chairperson, head of the department of MCA, Sri AVSM Ganesh Garu, and today's resource person, Dr. M. Haritha Madam, and faculty members of MCA department and all the participants of this one-day national seminar. So very good afternoon to one and all. So really I'm privileged to be part of the inaugural session of this workshop. So on behalf of the management and the principal and the IQAC cell, I congratulate the department of MCA for organizing this one-day national seminar on natural language processing. And the resource person is also a researcher in data sciences. So I request all the participants of this one-day national seminar to get some good inputs from this and to acquire some good knowledge. So for your technical improvement, and so much of research is happening nowadays in this data sciences, and this data sciences is the craziest subject nowadays. So a lot of opportunities are there in this field. So hope all the participants will get good knowledge from this one-day national seminar. So hope all you will have a great time in this 2 hours or 3 hours workshop. So I thank the Department of MCA for giving me this wonderful opportunities, and I wish all the participants all the best. And I thank once again the resource person of this natural language processing seminar, the resource person, Dr. M. Haritha Garu, so for accepting our invitation and gracing this one-day seminar. Thank you one and all, and I wish you all the best. Thank you.
Thank you, sir, for your valuable suggestions and guidelines to us. Now, today's chief guest, M. Haritha Madam profile has been delivered by Aparna Madam. She is our faculty member. So I hand over the mic to Aparna Madam. She will deliver the guest profile. Aparna Madam. Aparna Madam.
Yashwant.
Dr. Lakshmi Harita Medida recently received her PhD degree from JNTU Anantapuram in the Department of Computer Science and Engineering. She received her MTech degree in the Computer Science and Engineering from BBC ITS and affiliated to JNTU-K in the year of 2016, and pursued her BTech in Electronics and Communication Engineering from Pragati Engineering College affiliated to JNTU-K in the year of 2011. She had 2 years of industry experience working with TCS. Her interest towards data science made her quit the job and enter into the research field. She is the author of 10 papers published in different reputed journals and presentations and conference in many conferences. She is the author of book chapter Learning and its Real World Perspective, published by Springer. She has been a guest speaker in the faculty development program on free and open source software conducted at Sri Vidya Niketan Engineering College, Tirupati. Her research interests include information retrieval, data mining, machine learning, audio and image processing. Finally, a well-known phrase, sky is the limit. For a person with effort and faith in ourselves, anything is attainable. That's you, my dignity. Thank you all.
Thank you, Aparna madam. Now, as part of the workshop concern, we would like to start the workshop on natural language processing by Harita madam. So, I would like to call Mrs. Harita madam. Please continue your session. Harita madam, are you there?
Yes, thank you, sir.
Yeah, madam. Yeah, you would like to continue your session. Yeah, please.
Good afternoon, everyone. First of all, I would like to extend my thanks to all the coordinators of this workshop and especially Aparna madam for introducing me. Is my voice audible to everyone?
Audibly, madam. You can continue. No problem.
Okay, thank you. Let me share my screen.
Please share your content, ma'am.
Yes, I am sure.
Okay, ma'am, share.
Is it visible, sir?
Yes, ma'am. It's visible.
Okay. Now, today's session is on natural language processing and text analytics with Python. In the next few hours, you will have a basic understanding of what natural language processing is, and we'll do some hands-on exercises on text analytics using Python. Before moving forward, let's have a quick look at the agenda for today's session. We will start with the introduction to natural language processing, which is abbreviated as NLP. Then we will understand what is the need for NLP in the today's world, along with the applications of NLP. Then we will try to understand what text analytics is and the advantages of using Python for the text analytics tasks. We initially start with the text preprocessing tasks using different machine learning algorithms and then move to the advanced text processing tasks. We will try to extract the summary and keywords from the given text document, which is the text summarization technique, an application of NLP. Then we will look at what topic modeling is and how we can achieve this. Natural language processing. Is anyone aware of it? Hello?
No, ma'am.
Okay. Let's understand this in a simple way. Let's divide the word natural language processing into two subwords, natural language and processing. What is a natural language? A natural language is the language that we use for communication in our day-to-day lives. All the languages like English, Telugu, Tamil, Malayalam, etc., all these falls under the category of natural languages. And all these natural languages are evolved over time with certain grammar and linguistics. Is Python a natural language? Anyone? Is Python a natural language? Python is not considered as a natural language because it doesn't have any grammar. Or for any natural language, we have the base as the alphabets, right? And then we have the word processing. We have been learning about the definition of processing since we are introduced to computers. What is processing actually is? Processing is how a computer carries out certain instructions given. Now, combining these two terms, natural language processing can be defined as a technique or a process where we train a computer to process the natural language. In order to further simplify it, we can tell natural language is how we train a computer to deal with exclusively textual data. Natural language processing falls under the umbrella of artificial intelligence. And artificial intelligence is all about training a model or a system to mimic the human brain. Artificial intelligence is the field where we train a model just as to act how a human brain acts. And NLP is also considered as a subset or part of machine learning. Now, what is the need for natural language processing? In this data immersive world, every day, huge amounts of data is being generated from almost all industries and organizations. And the main problem with this data is it is highly unstructured and messy in nature. Industry estimates show that of the data being generated every day, 70% is in the textual format, of which only 21% is in the structured form. Therefore, majority of the data being generated is highly unstructured in nature. Therefore, it is very essential to analyze this unstructured data in order to understand and extract meaningful information from it. Text analytics, therefore, provides us with a set of techniques to derive actionable insights from this textual data. The field of text analytics is evolving at a faster rate in order to compete with the big data that is being generated day to day. Here are some of the applications of natural language processing. The first one is the sentiment analysis. Sentiment analysis is the most widely and commonly used application of NLP. Sentiment analysis determines the sentiment from the data provided. Consider this example provided here. Here, there are 3 reviews provided by the customers for a product released in the market. The first review is given as my experience so far has been fantastic. Based on the word fantastic, which has a highly positive sense, through sentiment analysis, a positive sentiment is assigned to this review. And then we have the product is okay, I guess. Based on this statement, we can't actually say whether the customer is satisfied with the product or not. Under such cases, we assign it with a neutral sentiment. And in the third review, your support team is useless, which is purely a negative statement. Therefore, it is assigned with a negative sentiment. This sentiment analysis is being used by many business organizations in order to adjust their business strategies by extracting useful insights from the customer reviews. This in turn is helping the business organizations to grow both in terms of business and profits. Then we have the speech recognition system. A speech recognition system identifies the spoken words and converts them into readable text. Alexa, Google Assistant, Siri are the most commonly used speech recognition systems in our day-to-day lives. Then we have text summarization technique, where a summary is generated from a given text document. This can be considered as generating a shorter form of a given text. When generating the text summary, the original meaning and key information is preserved in the text. We will discuss in detail about this text summarization technique in our later slides. Then we have machine translation. In machine translation, a machine or a model translates a given text from a source language to a target language. Here in the example provided, the word hello is translated from English to Spanish. Here, the source language is English and the target language is Spanish. We might have used Google Translator when we are traveling from one place to another. This is an example of machine translation system. Then we have chatbots. Chatbots provide us with a personalized assistance. Chatbot systems communicate with the customer either in the form of a text or sounds. Slack, Facebook Messenger, and Telegram are some of the few examples of the chatbots we have. Now let us understand what text analytics is. As discussed earlier, text analytics is the process of deriving meaningful information from the natural language text. This process usually involves the steps of structuring the unstructured text and then deriving meaningful patterns from this structured text, and finally evaluating the interpreted patterns. Here, the overall goal is to turn the textual data easy for analysis through the application of natural language processing. Natural language processing can therefore be considered as a component of text analytics. Through the application of natural language processing and its components, we can organize massive chunks of textual data in order to automate certain tasks that are useful to solve a wide variety of problems. Now, our goal is to enable machines to understand the human language and extract meaning from it. Now, what is the advantage of using Python as compared to other languages? In general, Python is considered as an easy to learn language and can be run on any platform. Most of the top companies like Instagram, Google rely mostly on Python for text analytics. This popularity for Python is because it takes very less time to write a program in Python as compared to other languages. As a full-fledged programming language, Python is a good choice for text analytics tasks. Python also provides integration with other languages and web applications. It also provides us with a variety of modules for text analytics tasks, making making our job more easier. When we look at different Python modules that help us in achieving the NLP task, the first one we have is NLTK, which is the Natural Language Toolkit. NLTK is a Python module that provides a variety of functionalities that helps us in text processing tasks. It also provides us with the advanced functions and libraries that are useful for deriving meaningful information from the text. NLTK is the most widely used module when working with the human data. Before working with the NLTK module, we need to have it installed in our systems. For that, we need to run the simple command like pip install NLTK from our command prompt. With this, all the corresponding packages from NLTK module will be installed. Then we have the scikit-learn library. This is the machine learning implementation in the Python language. The scikit-learn library provides us with a wide variety of supervised and unsupervised machine learning algorithms. It is built on the modules of NumPy, SciPy, and Matplotlib libraries. So these are considered as the prerequisites for the scikit-learn library. So before installing the scikit-learn library, we need to have these NumPy and SciPy modules installed in our system. The NumPy module could be installed with the command pip install NumPy. And then the SciPy module could be installed with pip install SciPy. Once we have these two modules installed, we can proceed with the installation of the scikit-learn module, which could be installed with pip install sklearn command from the command prompt. Then we have the Gensim module. This is the natural language processing module that is provided by Python. Gensim is considered as the state-of-art module for the text processing tasks and also to develop word vector models and topic models. The Gensim module is built on the primary goal of memory efficiency. Therefore, distributed computing could be made possible through the Gensim module. The Gensim module could be installed with the pip install Gensim command from the command prompt. Now, text preprocessing. What is text preprocessing? Before we proceed into any analytics task or any feature extraction methods, the first step we need to do is to clean the data. This process of cleaning the data is referred to as text preprocessing. The cleaned and encoded data is fed as input to any ML models or any other models. These basic preprocessing steps include converting the text into lowercase. This is the basic and first step in the preprocessing stages. Converting the text into lowercase reduces the duplication. Consider the example shown here. Here I have a sentence, data science deals with huge volumes of data. In this sentence, I have the occurrence of the word data 2 times. The first occurrence is the capitalized word and the second occurrence is the lowercase word. We know that the capital lettered word data and the lowercase word data is same, but how do the computer know that both the words are same? It doesn't know. It doesn't know the variation between the two words. It deals that those two are separate words. and this may result in the duplication of data. For this purpose, in order to eliminate such type of duplications, we initially convert the text provided into lowercase. This is the very simple step which can be done with the Python's built-in function .lower. Then we have the stop word removal. Stop word removal removes the insignificant words in the context of text. What are these insignificant words? What does it mean? There may be some words in our text which are used just for the grammatical purpose. They do not actually contribute to the meaning of the data or to the context. They are just used for the grammatical purpose. Here, consider the example shown. The words with and of are used just for the grammatical purpose, just to form a sentence. Such words are referred to as stop words, and these stop words will be removed through the process of stop word removal. Implementing this process reduces the size of data, making the further steps easier for us. For removing these stop words, there are predefined libraries that have predefined set of stop words. We can utilize the predefined set of stop words while programming, or you can define your own stop word list. You can do it either way. Then you have the spelling correction. Nowadays, huge amounts of data is being extracted from social media posts, comments, and reviews. When data is collected from such sources, there are very high chances of having spelling mistakes. So correcting these spelling mistakes is very important when such data is considered. This also is useful in reducing the duplication. For the same example considered, here I have given the word volumes as with a wrong spelling. Now, on spelling correction, this will be rectified. Then we have tokenization. Tokenization is the process of breaking down text into some predefined segments. These segments are considered as tokens. It is actually a way of separating a piece of text into smaller units. Consider this example. Never give up. On applying the process of tokenization, this sentence is divided into 3 separate words, and each word is considered as a token. And all the tokens are outputted as a list. And this tokenization is at the word level. And tokenization can be performed at a word level or character level or a subword level. At the word level tokenization, we have tokens of words. At the character level tokenization, we have characters as tokens. And in the subword tokenization, we can tokenize the given sentence based on a certain length, whether it can be
Madam, not audible, madam. Please unmute your mic, madam.
Is it okay now, sir? Sir?
Hello, madam.
Sir, is it okay now?
Yes, madam, you can continue. Is okay?
Yes. Tagging is a process of attaching parts of speech or a tense to the tokens related. It is generally considered as the grammatical categorization of text. Considering the sentence data science, on tagging this sentence data science, the word data is tagged with NNS, which means the plural noun, and the word science is tagged with NN, which means a singular noun. For the sake of your information, here I am providing with the list of POS tags provided in Python.
Sir, your voice is not clear.
These are the list of POS tags provided in Python. See, in the previous example, we have NNS. NNS is the plural form of noun and NN is the singular form of noun. These are the other POS tags that are provided. You can just go through them once at a glance. Then we have stemming. Stemming is the process of breaking down a word to its root word. This is actually done by removing the plural forms or a tense form. This is considered as a normalizing method for the text documents. For example, consider these words: playing, plays, played. For all these three words, the root word will be play. On stemming these three words, we have the output as play. And the words am, are, is will be rooted to be. And in this example, car, cars, car apostrophe s, all these will be rooted to the same root word car. This also reduces the duplication process. Then we move to the advanced text processing techniques. With the advanced text processing techniques, we extract the features from the textual data. Why is this feature extraction process actually needed? This is because we understand the textual data that is provided, but a system or a computer doesn't understand the data in the form of text. It needs to be converted into the machine understandable language or machine understandable terms. For this purpose, we use this feature extraction process and convert the text provided into certain vectors or features. Some of the basic feature extraction process include bags of words, and then term frequency, inverse document frequency, and then cosine similarity. We will discuss in detail about each of these. Bag of words. Bag of words is actually a basic and primary feature extraction algorithm. Bag of words, in the bag of words representation, the frequency of each word is represented. And this is done ignoring the grammar and the order of the words. Consider this example here. Here I have three sentences, and all these three sentences could be considered as a corpus. In this corpus, each sentence could be considered as a document. For example, for your understanding purpose, I have taken the sentences as example, but in real time, you will have a document in each of these places. And coming to the bag of words representation, initially all the words in the corpus will be tokenized. See, here are the token of words we have. A, and, deals, have, all these are the tokens that are present in our corpus considered. Now, the first row represents the sentence 1. Here, the occurrence of each word here the occurrence of each word will be represented with its frequency. Here we have welcome to the workshop. At the corresponding positions, one will be represented. And in the second row represents the bag of words representation of sentence 2. This is similar to the representation in row 1. Then in sentence 3, we have data repeated twice. So you can see it here. In the third row, at the word data, we have 2. That means the word data is repeated twice in sentence 3. This is the basic representation or the basic feature extraction process. Then we have TF-IDF. It is an alternative to the bag of words representation. In TF-IDF technique, the weightage of each word will be calculated. This is the technique where you could find more weightage to the words that are important in the document. This could be done with the following formulas. In TF-IDF, where TF represents the term frequency of the word in a document, and IDF measures
Ma'am, not audible, ma'am. term frequency measures the frequency of a word in a document. And inverse document frequency measures the rank of a specific word with respect to other documents present in the corpus. The formula for term frequency is given by number of terms the word occurs in the text to the total number of words in the text.
King, banana king.
The inverse document frequency could be calculated with the total number of documents to the total number of documents with which the word is present in it. Finally, the overall score will be calculated by the multiplication of the term frequency and the inverse document frequency. This is the back-end process for calculating the weightage for each word in the corpus. Then we have the cosine similarity. Cosine similarity measures the similarity between the two documents. It measures the cosine of the angle between the two vectors. Here, the vectors represent the features that are extracted from the text document. Cosine similarity is the most popularly used document similarity technique. Some of you might be aware of this formula. This is the formula on which cosine similarity will be calculated. Then we have the summary and keywords extraction process. This is one of the newest and most exciting fields of natural language processing. This is termed as text summarization. Text summarization is a technique where a summary of a given text will be generated automatically. This text summarization is carried out by extracting one or more important sentences from the considered text. Text summarization is of two types. The first is the abstractive text summarization, and the next is the extractive text summarization. In the extractive text summarization process, a summary is generated by extracting the important sentences from the text. In the abstractive text summarization technique, a summary is generated by rewriting the sentences in the text present. This is a difference between abstractive and extractive text summarization. The most commonly used text summarization technique is the extractive text summarization technique, and it is also very easy to implement. And we can also extract the important words, which are the keywords from the given text. Then we have topic modeling. Topic modeling is a technique where we extract the underlying topics in a given collection of text documents. In a collection of text document, each document is considered as a combination of topics, and each topic is considered as the combination of words. For example, if I have 5 documents, on topic modelization, I will divide these 5 documents into groups of topics. Here is the list of topic modeling algorithms: LDA, NMF, LSA, and PLGA. These are some of the examples of the topic models that could be implemented in Python. In the practical section, we will see the implementation of topic modeling through the LDA algorithm. Now, with this knowledge, we will move to our practical session. I think by now you might have got the programs and one document that I have provided. Sir,
Yes, ma'am.
sir, have you shared the files which I have provided, sir?
Yeah, ma'am. So already shared, ma'am.
Okay, sir.
In
Thank
WhatsApp.
you. Okay, thank you.
Okay.
Now you all please open your Python LDLS. Could you see my screen?
Yes, ma'am. Okay.
You just open the file text pre-processing that is provided to you.
Shall we proceed? Please respond.
Please use chat box.
Are you ready?
Participants, please use chat box.
I'll wait for 1 more minute and then we'll start. Okay. In this program, these are all the prerequisites for running a pre-processing tasks now. I'll explain about each of these when necessary. First, in the text variable, I have read some text here. And as we already discussed, the primary step is to convert the given text into lowercase. This could be done with the built-in Python function .lower. It is very easy. I have just converted the considered text into lower and assigning it to a variable lower underscore text. Now, we'll see the output. See, all the words are converted into the lowercase. And next. Next, we have the stop word removal process. For this, we are using the NLTK module that we have already discussed about. In your systems, if you are using NLTK module for the first time, you need to install it. For that, you just open your command prompt and just type pip install NLTK and press enter. See, it's already installed in my system, so it's showing like this. If it's not installed, it will be installed for you in your system. You just verify once. Run this command from your command prompt. Once it is done, let me know. Have you done with the installation of NLTK? Okay. Now, after the installation, here you can see I have used the import NLTK. After installing, I am importing that NLTK module here. And then I'll just uncomment this line.
In the NLTK, as I have already mentioned you, there are some predefined set of stop words. These stop words we are accessing with this command nltk.download stop words. And we are assigning the list of stop words that are provided with NLTK to the variable stop. And we can see this list by printing here. Just print the stop words and see. See, here is the list of stop words that are provided by default with NLTK. And now, if we want to add our own list to this stop words, we can do so. I'll just print. Stop. See, here I am adding 10 to the list of stoppers that are already assigned in the variable stop. And now we will print the list again and check. See, here 10 is added to the list of stop words. Now, here I am assigning to the variable clean text the words which are not present in the stop words list. See, here I am reading the word stop, and if the word in the text is not present in the stop, I am assigning it to the clean text. And now I will print this clean text and remove if all the stop words are removed. See, all the stop words like are, to, with, these all words are removed from the sentence. And we have additionally added the word 10 to the stop word list, and that is also removed here. You just execute it once and let me know. If you have done, just type done so that I can proceed with the next task. If you are running this program for the first time, with this command nltk.download stop words for the first time, all the stop words will be downloaded. Done. please respond. Or if you have any error also, you can just type it in the chat box. I'll try to solve it. Shall I proceed with the next step? Yes. Okay. Then we have spelling correction. This spelling correction could be done with the text blob module provided in Python. For this, we need to have it installed in your system. For that, pip install text blob from your command prompt. See, I have already have it installed in my system. You just run this command, it will be installed for you. If it's already installed, it will show like along with the version is available. Done with the installation of text blob. It's pip install text blob. I'm highlighting it here. Pip install text blob. Vinita. Done with the installation. Once text blob is installed, we will import that with this command here. From text blob, import text blob, word. And after importing the text blob, we will use it for spelling correction. In the text blob module, we have the correct function which corrects all the spellings. It is very straightforward and simple. Now when we run, see, here in the text, I have given the word constantly as misspelled. I have written it as contently. And now if you observe the output, the word is corrected as constantly. You try with changing the spellings of other words and let me know. Have you done with spelling corrections? Yes or no? Can we proceed? I'll give 2 more minutes. You just experiment with other words or other text. Then we have the punctuation removal step. Here I am removing the full stop and commas if are present in the text. This is also one of the primary pre-processing steps. We'll just execute and see the output. See, after data signs and years, full stop or remove. You can also add Is it audible now? Hello? Okay. In this list, you can also add other punctuation marks as you wish. You just try with other punctuation marks or with the same punctuation marks and let me know. This is also a very simple thing to do. We need not import any modules or so. Installation of, is it the installation of NLTK? Mr. Ratnam. From the command prompt, you need to type pip install text blob for the installation of the text blob module. If we want to install NLTK, pip install NLTK is the command for installation of NLTK module. This command you should give in your command prompt and press enter. Is it clear? Okay. Once we are done with removing the punctuation, we will tokenize the sentence taken. I'll just uncomment this. With nltk.download func, we are downloading all the prerequisites for tokenizing the text. This func will actually provide us with the tokenization or process, or it provides us with the token of words that we are doing. Then we are assigning the tokenized words to the token text with word underscore tokenize method. We are passing the corrected text to the word underscore tokenize method, and we are assigning the result to the token underscore text variable. Now we'll see how the output would be. See, these are the word tokens. We have initially cleaned the text by converting it into lowercase and then removed the stop words, corrected the spellings, removed the punctuation, and now we are tokenizing the given text. Each word in the text is considered as a token, and this is the list of tokens that we have in our text. You just executed it, see the output, and let me know. Then we can move to the next step. Shall we proceed? Yes? Or do you need some more time? Okay, we'll proceed with the next step. Now, we will have a look at the most frequent tokens in the considered text. Here, we are using the frequency distance, which gives us the frequency of the tokens. And here I am displaying the top 5 frequent words that are used in my text. We'll see the output once. See, these are the top 5 words, top 5 frequently words that are used in my text. Since we have considered only small text, you don't observe much variation, but you can see the word data is repeated twice. Rest all words are given once. We'll just change the text and check it once again. Data scientist constantly learn. I have just added some random text here where the word data is repeated one more time and it is repeated again. Now we'll again check the output. See, the word data is repeated 3 times and the rest all 1 time. Why the word with is not shown here? Because it is the stop word and it will be removed on the stop word removal technique. That's why we didn't get that. But you can try it by adding some more data of your own. Here, since I have passed 5, I have got the top 5 tokens here. You just try this and let me know. Could you follow me? Yes or no? Okay, thank you. If you have any errors or if you want me to repeat anything, you just let me know in the chat box. Done with tokenization? Shall we proceed to the tagging step? Yes. I'll just uncomment this. For tagging, we need to import POS tag from the NLTK module. Once we have imported this, we can go with the process of tagging parts of speech to our text. See, here I have used POS underscore tag method and passing the tokenized text to this method. We'll print the output and see what happens. See. Okay, I'll repeat it once again. For tagging the tokens that are present in our text, we need to first import the POS tag method from the NLTK module. That is what I am doing here. From NLTK import POS tag. And then we have imported this POS tag method from NLTK module. I am using it here. I am passing the tokenized text into the POS tag method. On passing this tokenized text, each token will be assigned with the predefined tags provided by the NLTK. I have already shown you with the POS tags that are provided. And on tokenization, on tagging, this is our output. See, I have already shown you in the slide, data will be assigned with NNS, which is the plural noun form, and signs NN, which is a singular noun form. Correspondingly, all the tokens will be tagged with the corresponding POS tags. Have you done this? Can we proceed? Yes. Not even a single S I could see in the chat box. Okay. Then we have the stemming process where a word is stemmed to its root word. As I shown in the example, all the words like played, playing, plays, all these will be stemmed to its root word play. For the purpose of stemming, we are using the Porter stemmer method. See, here I am importing the Porter stemmer method from NLTK module. And I am assigning the stemmed words to the stem underscore text variable as a string. We'll check the output now. See how the words are changed. These are the stem words that are present in the NLTK. So here you can change the you can find the difference. Previously we have changes and change here. Both these are stemmed to the root word change, CHANG. We'll check by adding some word here. I'm just adding changed. We'll check and see what will happen. See, we have changed also converted to change. That means all the words are converted to its root word change. Understood the concept here? Okay. With this, we have completed the basic reprocessing steps that need to be performed on our text provided. Then we will move to the advanced text processing tasks and how we can implement them. You just open the file TF-IDF provided to you. Sorry. Yes, open this file TF-IDF. Have you opened? Can I start? Yes. In this advanced pre-processing steps, we'll have a look at how the bag of a TF-IDF at the cosine similarity could be implemented. For implementing these three functionalities, we need a sklearn module, which is the scikit-learn module. First, we will download this. Open your command prompt and type pip install numpy first. First, install the numpy module. With pip install numpy command from the command prompt. Done. Once it is done, we'll install the SciPy module. Pip install SciPy. As already discussed, since these two are the prerequisites for the scikit-learn module, I have initially installed these two and then we'll move to the yes, I'll share pip install numpy pip install SciPy Now the actual installation is done with pip install. Sorry. pip install sklearn. See, with this we have installed the 3 modules, NumPy, SkyPy, and then the scikit-learn library. Done with the installation of these 3 modules. Shall we move to the program? Yes. Okay. See, I have considered 3 sentences. These 3 sentences which I have shown you in the presentation part. I have considered these 3 sentences as the corpus of text. Now, I need a bag of words representation for this corpus considered. The bag of words representation could be implemented with the count vectorizer method that is present in the scikit-learn library. I am initially creating an object for the count vectorizer method and then vectorizer object dot fit transform and passing the text corpus to this method. Now the output of the bag of words will be in our x variable. Now we will check the output. See, here initially I am, for your understanding purpose, I am printing the feature names. Feature names are just the tokens that are present in the just a minute. Yes, I'm typing the commands again in the chat box. pip install NumPy, pip install SkyPy, and then pip install sklearn. Okay. Now coming back here. To provide more visualization, I am initially printing the feature names here. These feature names are the tokens that we have discussed that are present in the corpus. And then we are changing the vector form into array and printing it. We'll just have a look at the output. See. All these are the tokens that are present in our considered text. And now you just verify the output. The first row corresponds to document 1 and second row corresponds to document 2 and third row corresponds to document 3. And for each word or for each token in the bag of words representation, the number represents the frequency of the occurrence of the word. This output should match the one I have showed in the PPT. Have you run this? Got the output? Clear? Okay, now we'll move to the TF-IDF calculation. We have already discussed that TF-IDF is the other form of representation of bag of words, and it represents the weightage of words based on the total number of words and the length of the document and all the features that are present in the corpus. For calculating the TF-IDF, we are using the TF-IDF vectorizer method and assigning the corpus to the fit transform. And I am converting the output to an array. Now we'll see what is the weightage of each word that is being calculated. See. These are the weights that are calculated for the words. I have already shown you the formulas for term frequency, inverse document frequency, and the resultant value here is the product of term frequency and the inverse document frequency. See, here this is the weightage given to the word data. Since data is repeated twice, it would obviously have more weightage. You just run it, go through the output once, and let me know once it is done. You can just try all this with your own text. You need not necessarily run on this data. Or you can just add some more lines to this corpus and try. Now, have you got the idea how these values are calculated? TF-IDF is considered as the advanced feature extraction process, whereas bag of words is the basic feature extraction process. Have you completed running this? Can I move to the next step? Okay. I'll wait for some more time. Okay. Then we'll move to the cosine similarity calculation. As discussed, cosine similarity gives the similarity between the two vectors, or directly speaking, it gives the similarity between the two documents, I say. Here, I am using cosine similarity function for calculating this similarity. And this is, here I am passing TF-IDF, which is the vectorized form of our corpus. Here we have calculated the weights of the words and assigned it to TF-IDF. Now our text form is converted into a vector form. That is what is the feature extraction process. Now I am comparing TF-IDF of 0. That is, see, in TF-IDF we have 3 documents. So TF-IDF of 0 corresponds to the first document that is present in the corpus. So what I am doing here is, I am comparing the first document present in the corpus with the other documents. And now let us check the output. See. Now let us analyze this output. We have 1, 0, 0, right? That is, first, the document 1 is compared with itself, because in TF-IDF we have all the 3 documents. So the first output, see here. Here, this is the similarity value on comparing the document 1 with itself. Obviously, when both the documents are same, we'll have the maximum value, that is 1. And then the document 1 is compared with the second document. The output here is 0. That means it tells that there is no similarity for the first document with the second document. See, when you observe this corpus, the first statement is like, welcome to the workshop. And then have an insight in the data science. When we generally logically think about it, there is no connection between statement 1 and statement 2. But when we see statement 2 and statement 3, there is a logical connection with the word data science and some data. And this is the value on comparing the document 1 with document 3. Now we'll do one thing. We'll compare the second document with the corpus and check the output, what will happen. See, this is the output on comparing the second document with the first document. It says that there is no similarity between both the documents. And then this is the output corresponding to the comparison of document 1 with itself. So we have 1. Now comparing document 2 with document 3, we have got some value 0.34. This similarity index ranges from 0 to 1. This value says that there is some similarity between document 2 and document 3 as compared with document 1. Clear? Is it clear? Is the concept clear for everyone? This is how the similarity between the documents is calculated. Okay. You just run this and let me know. You can also change this to this.
Now we are comparing the third document with the corpus. See, this is the output. Now these two values are same. That means what it shows, document 2 and document 3 have a similarity index of 0.34 something around that value. Have you finished executing this? If you have any doubts or need any clarifications, let me know. Shall we move to the next program? Yes. Can someone respond in the chat box? Okay. These are the advanced pre-processing steps that we have discussed. Now let's move to the other task of text summarization. You just open this file, sum.ext. Have you opened it? Yes. This is the program for text summarization technique. We are implementing the summarization using the Python's Gensim module. Before going into the implementation part, let's install this Gensim module. In the command prompt, type pip install Gensim. This will install the Gensim module. This is the command for installing Gensim. Pip install Gensim. Done with the installation? Yes. Do you need some time or shall I proceed? Okay. Now, once I have Jensen installed in my system, I am importing the summarization. Sorry. I am importing the summary and keywords methods. And here I have a text file ds.txt. This file is also provided for you. If you want, you can use that file, or you can use your own text file, or you can just randomly open a text file and enter your own data. Give the path of the text file here. I have the ds.txt file in this location. Have you changed this text file location? Okay. Now, here I am reading the contents of this text file into the variable text. This is how we read the content of a file in Python. Here I am opening the file in the read module and giving the file path where the file is present. And f.read reads the entire content in this ds.txt file into the variable text. If you are already aware of this, how to open a text file, it's good. Okay. Isn't my screen visible to you? Why? Okay. Okay. We'll proceed then. Here I am reading the contents of the text file into the variable text. Then using the method summarize, Dinesh, I have already closed that shell tab, Mama. Couldn't you see the program? Why, what happened? Okay, I'll just stop the sharing and give it.
Any problem, ma'am?
Some of them have pinged that they couldn't see my screen.
Sorry.
It is not visible, ma'am. You are sharing shell tab, ma'am.
Oh. Is it visible now? Okay. Is it clear how we read the text we read the content of the text file into a variable here, or should I repeat it again?
Okay, then I'll proceed. Once I have the entire content of the text file into the variable text, I will assign this text variable into summarize method, which I have imported here. And here I'll print the summary. Also, I have the keywords method in the Gensim module, which gives the topmost keywords. We'll check the output once. See, this is the output I got. Before analyzing this output, you just open the text file that is provided to you and go through it for a while. Then you'll understand whether the summary generated by the system makes sense or not. And here are the top 10 keywords that are generated from the given text. The text mainly talks about the career opportunities in data science and the roles in data science also. Therefore, I have got the career, role, data science, all these as the topmost keywords. You just go through the text file and also the output so that you will have a clear picture. And as I have mentioned, there are two types of summarization techniques, which is abstractive and extractive text summarization. Here we are performing only extractive text summarization. This is very easy process and very easy for the computer to train. As already discussed, even if we have to write the summary of the given text file, will take around 10 minutes. But Python is providing us the predefined modules for performing all these tasks with the reasonable outputs. And we have done this in just 4 to 5 lines of code. That is why most of the companies are using Python in the real-time applications. Have you got the output? Yes. Shall we proceed? Okay. Then we'll move to the task of text modeling. Open the file topic model that is provided to you. Could you see my screen? Okay. we have already discussed that topic modeling is the process of dividing the documents into subtopics. Here I have considered 5 documents. Now we will categorize these 5 documents into topics. Let us see how we can do it. For topic modeling, we have a combination of NLTK and GenSim modules being used in this program. Here, I am making a list of documents in order to form the corpus. Then, as we have already discussed, the initial step would be the pre-processing steps like converting the text into lowercase, removing the punctuation marks, removing the stop words, and all this. Here, that is what I am doing here. Initially, I am cleaning the text that is read into the list of documents. Now, once the documents are clean, I am using the LDA model. We have already discussed the different topic models. One of the basic model is LDA, that is the latent Dirichlet allocation model. So we are using this model before, and we have already discussed that before implementing any feature extraction process, before implementing any technology or any processing steps, we need to first convert our text into vector form. For that, I am using the doc to bow for converting our text into feature vector. Here I have got the feature vector matrix. That is, so far what we have did, we have got 5 text documents and then cleaned the documents and then converting the documents into the vectorized form. That is, we are doing the feature extraction process. Why we are doing this feature extraction process? In order to make the machine understand what is inside the text. That is, we are simply converting it into numerical or machine readable format. And then we are creating an object for the LDA model that is predefined. And for that LDA model, we are assigning our corpus and we want to divide our corpus into 2 topics. See, here we are assigning the number of topics as 2. And here we are printing the output of the model. Along with the topics, we are printing the top words in the topic. Here we are printing the top 2 words in the topic. Let us run this once and see the output. Once we have the output, you will have a better understanding of it. Sure. See, as we have passed the number of topics as 2, here the corpus is divided into 2 topics, 0 and 1. And the top 2 words in each topic are printed here. In the first topic, we have the topmost word data with the weightage of 0.096, and then we have scientist 0.068. And then in the second topic, we have dance and sister as the top 2 words with their corresponding weightages. Now you observe this corpus here.
You observe the corpus once. Here, the document 1, 3, and 4 are all related to data science, and document 2 and 5 are related to dance. So, can you see the shell here? Can you see the output generated? No. Now can you see?
Yes, ma'am. Visible.
Okay. Now we'll modify this number of words to 5 and check the output once. That means we are dividing the documents into 2 topics and we are displaying the top 5 words in each topic. Now when you observe the output, in topic 1, data scientist, science, impact, team, all these are given the highest weightage. And corresponding to topic 2, sister, dance, data, practice, father, all these are given the top 5 weightages. When you clearly observe the corpus and the output, you can say that it makes some sense, right? You just go through it. You just run the program, check the output and let me know. See, I'll explain the output once again. Here, what we are printing. First, we are categorizing the entire documents or the documents we have considered. For example, here we have considered only the 5 documents. These 5 documents, what we are doing, we are dividing these 5 documents into 2 topics. That is, the number of topics is equal to 2. And then we are displaying the top 5 words in each topic. What will the output contain? Topic 1 and the corresponding top 5 words, and topic 2 and the corresponding top 5 words. Now we will analyze this output. See, here the first topic is represented with 0. And what are the top words in this first topic? Data, scientist, science, impact, and team. These 5 are given as the top 5 words along with their weightages. See here, 0.096 into data means that is the weightage, that is the importance of the word in that topic. With this, it is very clear that topic 0 is something related to data science. That means document 1, 3 and 5, document 1, 3 and 4 in our corpus which are related to data science are categorized into topic 0. And under topic 1, we have the top words as sister, dance, data, practice and father. All these words are related to something dance, father, sister relationship, something of that kind. That is, our document 2 and document 5 are categorized as the second topic. And these 5 words are considered as the topmost words in this topic. That means they are the words that mainly contribute for the division of these topics. Now you got it? Okay. Now, what I am doing here is, I have considered some more text. This data science career and data class. Consider this as a separate document, document 1.1, and consider this as the other document as document 1.2. Okay. Now, we will check how these two documents are related to our corpus or are related to the topics. Already we have a corpus and divided that corpus into two topics. The first topic is related to data science and the second topic is related to dance. Now, I have considered two more documents. And let us check how these two documents are related to the topics that are already generated. For that, I am calling the LDA model that is already built and assigning this text, this new text to that model. We will check the output once. See. See this. When you observe this, what is our first document here? What is our first new document considered? Data science career. We could clear, it is very clear that this is related to topic 1 that is represented by 0. See here. This new unseen document is very much closer to our first topic. It got a weightage of 0.74 and is very less related to our second topic, 0.25. That means we can easily categorize or assign this. Hello. So when we add these two documents into our corpus, this first document could be assigned to topic 1 and second document could be assigned to topic 2. See, this is the output where our second considered unseen document, document class, is very less related to the first topic, because our first topic is related to data science and it is very close to our second topic. This is how you can add some more documents to the existing corpus and assign them to the already existing topics. You can try this with your own data also. Is the concept clear for everyone? Is the output clear? If you have any doubts, you can just ping me in the chat box. Okay. With this, I would conclude the section. Hope you all got some insights into NLP and practical session of text analytics. Hope this would be useful for your future works and all. Thank you.
Ma'am,
Yes, sir.
are you complete?
Yes, sir, I have completed.
Okay. Students not even. Participants. All the participants. Any queries? Please ask me. Please raise your hands. Then enable the unmute. Yes, Sakshi Supriya, please tell me.
Yes, sir.
Yes, tell me. Rajavamsi. Are you there? Please unmute. Rajavamsi. Please ask the question.
Any participant, the question by unmuting your mic.
Okay, any participant? Unmute and then ask the question. Anyone? Mata Badri. Okay, Maria.
Today's participants, can you share today's event, your views? Whatever your views, you can share in this platform. Any one of you from the entire participants. Can share your views today's session. Mr. Dinesh, mute yourself, unmute yourself. Mr. Dinesh, unmute yourself. Who are the share your views? You can unmute yourself. Manda Sai. college board people, share your views. Number 48. Aditya Student ID. Give some feedback. Number 48. Aditya 48.
సారీ వేసుకుంది
Unmute yourself, please.
BBC college students. BBC college students. Can you share your views? Any one of you? BBC ITS students. Unmute yourself. Principal గారు ఇంకా ఇన్వైట్ చేయకూడదా? Principal గారు Now we are going to validatory function. Good evening to each and everyone. I, N. Lakshmi, Associate Professor, Department of Computer Application in BBC Institute of Technology and Science. I privilege the opportunity to welcome you all to the validatory function of one-day national workshop on natural language processing and text analysis with Python. I convey my best wishes and thanks to the Honorable today's chief guest, Dr. M. Lakshmi Harta, sharing your knowledge with us. I big sincere thank to our management because of without management support, we can't do anything. I also extended thanks to our beloved principal sir, Dr. JVZ Ramarao sir, IQAC coordinator, Mr. ANVJ Rajgopal sir, AO sir, Mr. JV Krishna Rao sir, and all the HODs of various departments. Today event convener, Mr. AVSM Ganesh sir, and coordinator, Mr. GLNVS Kumar and P. Aparna ma'am. Last but not least, our department faculty members, technical staff, and each faculties of various colleges and students that to support to the grand success of this event. Thank you so much for giving me this opportunity. Thank you. Harita ma'am.
Yes, ma'am.
Yeah, thank you so much, ma'am.
Thank you, ma'am. Thank you
Okay,
for
ma'am.
inviting
What
me
is sir
this
will take
workshop.
the opportunity right now, ma'am.
Okay.
Once again, good evening all the participants. I hope this lecture will give fruitful to you regarding all aspects. Am I audible, madam? Artha madam, am I audible?
Yes, sir. Yes, sir.
Yeah. So under your lecture, I found some fruitful lessons regarding under machine learning algorithms. So I hope our students and other participants are also learn more and more sessions. So once again, thank you so much, Harita Madam, on behalf of
Thank you, sir.
BVCITS management. Yeah, on behalf of BVCITS management and principal, as well as administrative officer side, and as well as IQC coordinator side, and as well as last but not least, on behalf of our MC department, I sincerely thankful to you, your wonderful lecture so far. Thank you, madam. Thank you, Harita madam, once again.
My privilege,
So we
sir.
will
Thank you.
conclude. Okay, we will conclude this session. Thank you so much. So,
Thank you.
my dear participants, all of you, please submit the feedback. So definitely we will provide the e-certificate. Those who are completed the feedback form, so we will provide the e-certificate within 1 week. Okay. Okay. Thank you all the participants who are participated in this fruitful workshop. Thank you one and all. Have a nice day. Thank you so much.